I do market research for Intersect360 Research, and we have recently completed a couple of reports on middleware and application software, and I'd like to provide you some highlights from those reports plus some other research we've done. To get going with our research definitions, we break the market up by a number of categories: academic, government, industrial, whether software is open source or ISV, that sort of thing. But one of the very high-level segmentations, a super segment, is between technical high-performance computing and business high-performance computing. Technical is pretty much the traditional scientific engineering. Markets there are, academia, government labs, defense, manufacturing, all the usual suspects. More recently, about the last 4 or 5 years, we're seeing more and more high-performance computing type of applications come through in the business sector. So we're seeing applications in trading, price analysis for financial instruments, risk analysis, risk management, logistics, fraud detection, online gaming, those areas, and this is beginning to develop. It's being driven in part by big data, however you want to define that. And so those are 2 areas that we look at, and we're looking at particularly closely. Let's see, this is probably just about invisible to you guys in terms of the fine print. And that's good, because that means I can make stuff up. And you have to go to the slides to see if I'm a lying dog or not. In any case, this is a breakdown of vertical markets by the HPBC and HPTC categories. First off, give the guy too many buttons and he becomes completely dangerous. Okay, here we go. First off, the technical side is about 70% of the market. So these 2 pie charts aren't drawn to scale. If you like to, you could think of it as the technical market here. The pie chart actually comes out about twice as far as the pie on the business side. Important thing about the technical market is it's really broken up into 3 major categories. Academia, which has virtually all of the applications spread out through it somewhere. Government applications, which run from the gamut of research applications into the defense area, into the health and other areas as well. And then there's also the biggest part of the market is really industrial applications. And we like to point this out because when we talk to a lot of people about HPC, they completely ignore it or have no idea that there's a strong commercial part of the market, and this is where we're seeing the most growth. HPBC, on the other hand, is entirely commercial, maybe 5-4% of the users reporting government. And their applications fall into the financial services, online gaming. One of the bigger segments here, this guy here, alternate internet, it's sort of controversial from a lot of our clients' point of view. It's companies that really aren't doing HPC but have such large computer centers that you look at the computer they're running and you're saying, well, that's really a supercomputer. We are looking at pulling that out and just making it a separate segment. Because the most interesting about it isn't so much of the size, but the impact it has on market directions and the economic power these companies have to mold technology to meet their requirements. Just a quick note of where the data comes from. We do 2 major studies during the year, a site census, where we basically ask people the simple question of, tell us everything you have in your computer center, hardware, software, networking, and so on. In the software area, we ask for the top 5 software applications packages and middleware packages, so it's not exhaustive. The second one is a budget map report, where we ask people to break down their budgets on a percentage basis into about 30 categories. And software is one of those categories. We use this data to inform our market sizing and our forecasts. Then we have a couple of special studies, one on big data, and then one that actually hasn't been released yet, that's pending, but we'll give you a sneak preview of a couple of the slides for the Council of Competitiveness on essentially the effect of exascale investment on industry. And whether or not industry goes to exascale or not isn't so much the question as, is it important that this research and this work being done for industry, and where it can be applied at lower levels of scale. Always start out with a market sizing slide. Couple of important things here. Now, right down at the bottom there, you can't see it, but it tells you that about a third of the market falls into this blue category of servers, and the second largest category, which is about a third of the size of the servers, is, or about a tenth of the market, I guess that would make it, is software. Software is the second largest category in the market. We are looking at the market at being about $30 billion in 2013. We think it's going to grow to about 4.6% compound annual growth rate to 38.1%. This is basically just a trend analysis with a lot of discussion with people in the industry, a lot of analyst opinion thrown in. It's a tough job, but somebody's got to do it. Other interesting thing is this little gold guy here, which is cloud. And here we're specifically looking at public and private cloud in a utility computing model. And two interesting things. One is, well, it gets a lot of attention. It doesn't get a lot of people's money. They don't report they're spending a whole lot of dollars in their budgets, or euros in their budgets, on cloud. But we're seeing that change to some extent. And the people are beginning to say, yes, we're putting more money, we're changing our budgets, we're putting more money in cloud. This is all anecdotal at this point. We'll have to do a few more surveys to see how true it is or how general. So we expect to see, I think that used to be on here somewhere, about an 18.6% compound annual growth rate. Little secret about marketing. If you want to have a high growth rate, start with a really small number. So that what we're looking at is something starting small but beginning to change. So this might be an inflection point in the market that we'll be launching. More information on market performance. A lot of data here. This first table just looks at the major categories in the product classes by 2002 versus 2012 versus 2013. The absolute change in revenue and then the percentage growth. Software sort of on the low end, but it's still growing. I think there's sort of a conflict in the market that on the one hand, people were very concerned a few years ago that with the movement to multi-core processing and licensing per core, that the cost of software would explode. And on the other hand, people were concerned that it was all going to go to open source as a result. And we have some data later on, some slides that deal with some open sourcing. So far that hasn't happened. We're looking at a pretty stable software market in our forecast. Next interesting point is just this storage guy here, minus 2.3%. Turns out that in 2011 there were floods in Thailand, and that destroyed a lot of disk drives, or at least kept them out of the market. That in turn produced a dip in 2011, a wild increase in 2012 to make up for it, and then another dip in 2013. And so we're looking at a decaying sine curve, and ultimately we'll expect that to work its way out into a more 4.4% growth rate over time, 4 to 5%. What else? In general, the market has been growing 4 consecutive years. What hasn't been growing is government spending. The sequester in the U.S. has really cut into that. But that said, academia has really held its own, surprisingly enough, and commercial is pushing along at a pretty good growth rate. Because HPBC, the business computing, is all commercial, it looks good, and because about 30% of the technical computing is government, it as a whole doesn't look that hot. So getting into the applications area. Overall application categories, the top 10 here start out with chemical research. Next, interestingly enough, is business intelligence, which is a conglomeration of data warehousing, big data, customer relationship management type applications. Then biosciences. You know, the chemical and biosciences are very closely related, so combined they would look about 30% of the market. Next we have hip-hop music analysis, and then we go right into weather. It's as funny as I get. From here on in, it's one long anticlimax. We have fluid dynamics, and then weather. Some information on the survey. We combine results from the last 3 years. People buy software packages and tend to keep them around for a while. 108 primary applications, 1,108 primary applications were reported from 435 sites. So we're looking at a fair amount of data here. 3/4 were HPTC, the rest were HPBC. And this is really important. About 80% of the applications were only mentioned once. This is a distribution with a very, very long tail. We have a few in both middleware and applications. We have a few packages that might get into double-digit market share or high single-digit, and then a lot that just sort of tail out. Application-wise, that is kind of an effect of technical computing. Scientific research always looks at the next question. The watchword for technical computing, HPC, is once you've solved the problem, it's no longer interesting. So that you go on to the next problem, the next most complicated problem. And so the market bifurcates and bifurcates and bifurcates into new application areas. This slide is essentially the previous slide with more detail and broken out by HPTC, HPBC. You can look at the details on HPTC. What's interesting here is pretty much how undifferentiated the HPBC market is. Relative to the technical market. That's an effect of it being a new market. It's the effect of it being sort of a trendy market with things like big data. So we end up with huge business analysis, business intelligence section. And that's pretty much when people are reporting results. They are reporting things like, we're doing analytics, but they're not saying what the analytics are on. And when they talk about big data, they're saying we're doing MapReduce. Now, in reality, MapReduce is not an application. It's a software middleware database sort of application for generally doing searches on non-structured data sets. But people have not got a clear enough idea of what's going on to really report things very specifically. We expect over time to see things like MapReduce disappear from these charts and be replaced by more specific application sets. And frankly, the big data market, in my humble opinion, is at a turning point where it needs to get away from saying we're going to get big data so we will have faster and better insights, into saying we are doing these specific applications which are repeatable year after year and which produce these types of results. There's got to be the equivalent of a sound barrier or a speed of sound in human behavior or markets or corporation behaviors to how many insights you can absorb over a period of time. So that just getting 1,000 new insights today isn't necessarily going to help the organization. One of the reasons they don't let me talk that much, I never really know what I'm going to say. Okay, switching now into the middleware market. We break the middleware market up into 8 major categories. And the interesting part here, my perspective, is how much of this market, 36%, is programming environment. That technical computing and even business computing, we're finding, is very much an in-house business in terms of what you're doing with the computer. One of the definitions of HPC is it is a core part of your business or activities or research that provides greater competitiveness. And in order to maintain greater competitiveness, it is often good to compete at the software level as opposed to buy the same package that everyone else has. When we combine programming environments with compilers, we're over 50% of the market. The difference here is programming environments include program suites, debuggers, profilers, optimizers, the whole suite. This is just C, Fortran, where people give us a specific language. And to a certain extent, this is a toolkit that it is very hard to get a technical computing environment where you can't let anyone write a program. Those engineers or scientists are going to write something sooner or later. Job management comes in second. That is mainly network batch queue management. System management is the last double-digit category, and that's a variety of things, from system monitoring applications to provisioning applications and so on and so forth. HPC application by supplier type. So I don't know if you can see the bottom category here, but this is HPBC, HPTC, and then we're looking at it as public software, open source software, in-house, and commercial. Public and open source are essentially the same thing. Public is a little bit better controlled by one organization, and there is a tendency to provide a tiered pricing on the licenses, from very little money to academic research institutions and more money for industrial sites. I put that in when we first got started 7 years ago, and I think I'm ready to take it out. It just hasn't really generated that much interest. So just think of those as the same thing. But what we see here is that this blue column, in-house, is really dominant in the HPBC marketplace. So they're really doing a lot of development in and of itself. I don't know where MapReduce is showing up in here, but if it is showing up, it's showing up at a lower level than one would expect. In the HPTC, we get much more open source software, particularly in the academic and national lab sort of environments. Organizations are contributing to the open source and deeply involved in it, so there's a much greater tendency to use it. And then we just sort of average out. The red column is ISV software. ISV software in the technical area tends to show up in commercial sites, industrial sites. So if you're in the automotive aircraft industry, it's important to get certified code where if something goes wrong, you can point back to the code and say, well, no, it wasn't a problem in programming. Middleware by sector, same sort of chart, except here we're breaking it up by academia, commercial, and government. First off, very, very little in-house software development or public software development. You know, these tend to be complicated kind of dull programs, and it requires a significant effort to make sure they're working right. You know, a single scientist can make a mistake in their code and go back to the drawing board and fix it. If you mess up your job scheduler, then you may be taking people down for a long period of time and getting an awful lot of bad phone calls. So we see this market really dominated by the open source and the commercial codes. This is an interesting special case we've run into. I talked earlier about the concerns about multi-core processors coming out and then that really changing the pricing model. In the CFD area, I think we've seen the effect of that concern in a couple of ways. Back in 2008, just about everything was ISV codes. And I think, and this is purely my opinion, we don't have a whole lot of data on it, it's a little anecdotally, that 2009 people said, hey, the pricing model is going to get out of control. We are going to start looking at building our own codes. Over the next few years, they continue to build their own codes, but then OpenFOAM comes along. And they say, well, you know, OpenFOAM is really better than our own code, to where we begin to see OpenFOAM showing up at, about 62% of the CFD software mentions. And that we see the ISV software mentions leveling out right around 50%. OpenFOAM and in-house codes are sort of battling it out with OpenFOAM winning, but they combine to reduce the ISV market. This is really surprising. We really don't see ISV codes getting replaced by new packages in general and by open source packages in particular. So we're not really at the point where we're ready to say, stop the presses, everything's going to change, we'll redo the forecast, the market model has been disrupted, all of that stuff. But we are looking at this very closely. We have one package that's made a big impact in one area. We have to see if the process is repeated. Big data, much more than Hadoop. And this is from our big data study. This chart is more complicated than it needs to be, but we pulled it right out of the report. We're looking at sources of big data, software, in-house purchased, open, and unknown. If you ever see market research where all the curves are smooth and there's never a bad answer, that is something you should suspect. Early on, I was told by a colleague about him meeting the CEO of Digital Equipment. This is a long time ago, and the CEO said, you know, I love this company's data. I think it's great because I look at it and all of the curves are perfectly smooth. There are no outliers whatsoever. That means you've massaged it out of existence and I don't have to worry about it. So, you know, some people just don't know where they get their data from. In-house, in the business area, the split between the in-house purchase and open source is almost even all the way along. So that we're not looking at Hadoop or MapReduce coming in as one big package dominating the market. It becomes even more significant in the technical work, where about 50% of the market shows up as in-house codes. One note here, in this particular study, we contacted people that were not identifiable as HPC users on the business side, but we're still doing big data. And we've done the study a couple of times, and over the course of two studies, the exciting 2 data point line, which solves all problems, We've seen that these non-HPC sites are adopting more open source. Again, that's something we have to look at, but if it turns out to be more than Supplier, it'll be an interesting trend. How much time do we have left?
15.
15? Just about enough time to explain this slide. I'm going to blame this on my partner, Addison Snell. He was a mathematician by training. Every now and then I send him a note like, can you tell me if the size of the infinity of a line segment, say from 0 to 1, is the same as the size of the entire number line from minus infinity to infinity? And that throws him off what he's doing for a couple of hours while he figures it out. Do you want the answer, or do you want to work it out for yourself at home? Or do you understand the question? Don't all answer at once. I'm going to make you work it out at home. So this chart here is essentially a 2D projection of a 3D data space. And what it's looking at is the percentage of commercial, open source, and in-house codes in use by various segments of the industry. And so this is from the Council of Competitiveness report that I mentioned earlier, so it's only looking at industrial users. If it was a completely equal distribution, the dot would end up right in the middle. Otherwise, the closer they get to these apexes of the triangles, the more they favor one form of software over the other. So a couple of things to notice. One is nobody in the commercial area favors open source code. If you're interested in promoting commercial high performance computing, the findings on open source notwithstanding, you're probably going to have to look at ways to get to industrial codes other than open source. You're going to have to, on the in-house side, teach people how to program, help them with their algorithms, and then work with the ISVs on the commercial side. A couple of interesting points. That black dot is the overall response, which is just about right in the middle of commercial versus in-house. I don't know if you can see that yellow dot there. That is energy, that's oil companies, and they are the furthest out into the in-house side. And open source does appear, but less than 20% of the time. The other thing is actually this sort of clustered towards the middle, so there is some of each type of code being used everywhere. It would be a lot nicer for a market researcher if every group showed up at one of the corners, but it doesn't. On the other hand, if the market were a rational place, I'd be out of a job. And let's see, barriers to scalability. This is another, I believe this is another one from the Council of Competitors. We ask a lot of questions that go on the line of how important on a scale from 1 to 5, or how bad on a scale of 1 to 5 in some cases, is such and such. And in moving to, in this case, we asked the industrial users the chief barrier in getting a 10x performance increase, or scalability increase. But effectively that means, can you get your codes to run 10 times faster through scalability? The interesting part about, this is actually more what it's not than what it is. That in every study I've done since 1988, when you ask this type of question, the top 3 answers are price, performance, and price, performance. The order just varies between studies, but they all amount to the same thing. In this case, it turned out to be scalability of software. Users are more concerned about how they're going to get their software to scale. And I should just back up here and just say that the way the scale works is this dark blue is very good, not a problem. And out here on the light blue, it's a big problem, and the purple is, well, pretty much a problem. So if we look at where the purple and green boundary is, we can pretty much say, well, this is the problem areas. And scalability of software jumps out as the highest. That's beating out cost of hardware, cost of software, scalability of hardware, and even making the case to management. Beats out everything. Getting software to scale is a big, big problem. If any of you guys are working at it, work hard. If you have any extra money to spend, I would suggest that we hire more mathematicians to make sure to look to see if there are better algorithms out there. But that's the biggest case problem we're running into next. So just in summary, some key insights. HPC usage in commercial markets is growing. Particularly, it's growing faster than the public market. Big data provides a breakout opportunity for high-performance computing. Open source is on the rise, driven by pricing models. And it appears to be even showing up more in business. Software is the most critical limiting factor in scalability, as we just said. So with that, do we have any questions?